Good morning, everybody. We'll get started here briefly. Okay, I think we're going to go ahead and get started. Most people are here already. Let me share my screen. Oh, there it is. All right, so I'm on the wrong week. Sorry about that. Okay, so today we are continuing the whiteboard worksheet 1 that we started on the other day. We only got through 3 of the problems in that worksheet. So the last one we worked on was this one here. And we did a couple problems using calculus. So for instance, if they give us an equation for momentum, if we take the derivative of that, we could find what the force was at a given moment in time. Or if we're given what the equation for force is, we can integrate it to figure out what the change in momentum was. What we're going to do is we're going to continue on with this worksheet. Again, you've been put in groups already. So I'm kind of hoping your partners are here and you can kind of whiteboard in groups. So the one that I want to start with would be problem number 4. And I just kind of want to do a little bit of a reminder here. I didn't put a picture on yours. You can if you want. I just want the web so you can imagine a little bit. But I just want to review with you a little bit that we found from our first lab, our first simulation, that the um, impulse, that's what I have as J there, the impulse, which is the area under a force time graph. If it's constant force, it would be a force times time equals it is equal to the change of momentum. So there's 2 ways to find change of momentum. Either you can find the impulse, or if you don't know what the impulse is, you don't know the force, you don't know the time, you can also just simply take and figure out what the initial and final momentum is. Final mass initial give you the change of momentum. Okay. So I would like you to kind of collaborate on this, maybe sketch a picture, find something on the web, something like that, and maybe talk a little bit in your groups. So let me stop sharing and let's see if I can, I'm not sure why. It should have automatically put you in rooms. I'm not sure why it didn't. So sorry, I thought I had this all set up. So give me a moment and I'll see if I can get you in your groups. Um, So did you guys not get an invitation to join a certain group already? Because I thought I put that in already. I don't get it. Okay. All right. Because I see Wendy, you are in a group. Can you talk, Wendy?
Yeah.
So how did you get in that breakout room? Because I thought I had put you in it, but other people are saying they weren't put in rooms. So how did you put yourself in that breakout room 3? Don't know. Okay.
I don't know.
Okay. All right. Sorry. All right. So let's see. All right, so give me a moment. All right, so I put you in groups. I don't know that it's necessarily the right groups because I thought it was set up already. That didn't work out. Okay, so wait a second. Hold on a minute. I have to move one. Oh, okay, that was messed up. All right, sorry. Right, it's crazy. I thought I had this set up already. Okay, so here you're going to get an invitation now. Sorry. Okay, before we go any further, I need to kind of take attendance. So can you guys turn on your cameras, and whether it's pointing at your face or not, can you give me a thumbs up or something like that? I'm going to take a picture on the count of three. One, two, three. Smile. Okay, give me a second so I can save this. All right, thank you. Okay, so is there anybody who would like to share their desktop? Go through the problem? if you do, just take control down at the bottom, hit share screen, and then the blue pop-up, hit the share screen. Okay, thank you.
So for this problem, they give us the net force and the mass and the period of time. So that's here in this given. And the change in momentum is constant, so you can just use F times T, and that gives you a change of momentum of 5.94. This is my pretty bad drawing.
Looks good to me.
But
okay, so does anybody have any questions then? So notice the units for this. That's kind of interesting. That means that really change of momentum can have two units. You can either have newtons times seconds, like we have there, perfect. Or you can also figure out change of momentum by doing mass times velocity, so that would be kilograms times meters per second. So either one is fine. So can everybody down in the reactions give Aiden a hand? Nice, yay. Okay. And then Aiden, if you could stop sharing. Should be kind of, I think it's a red button or something like that.
Okay, yeah, I see it.
Okay, so any questions? Okay, so could you get back in your groups and then do the next problem? Okay, could somebody, a different person, thanks Aiden for the last one. Could somebody else then share their screen that has answer that they think is correct?
I could do that.
Okay, thanks.
So this is basically like a question that goes off the last one, and it gives you that the initial velocity was 0 meters a second. So using like the other side of the equation, you already know that 5.94 is what the change of momentum is. And since we know that the kilograms for the baseball is 0.14, you can just do 0.14 times the final velocity. I guess that should be the final velocity. And this would be the initial velocity, but it's just 0. So you can just reduce that down to 0, divide by 0.14, and you get 42.43 meters a second.
Sounds great. And I was kind of curious because I want to know what that was in miles per hour. That's around 95 miles per hour. So sounds about right, I guess. So any questions for JJ? Give him a hand at the bottom. Give him a hand. Yay. Yay. And if you could stop sharing, perfect. So, all right. So the next one, in fact, why don't you just see if you can see what you can do on that one? I think it's a continuation of the last two. So I'm going to go ahead and put you in their breakout rooms. Okay, so this one is a little bit more involved because you had to find the impulse and then you had to figure out what that final velocity of the ball was. Somebody want to share their whiteboard? Go ahead and click on the green share at the bottom, and then when a pop-up comes up, hit the blue share. Gabe. And just kind of walk us through how you went about solving it.
So the change in momentum was equal to the impulse. So that was just the force times the time. So it was a negative 11.88. And then we set that equal to MV final minus MV initial. And we ended up getting the final velocity is negative 42.43.
So the initial was like something like the same, right? Except it was in the opposite direction. So in a way, this is kind of like a bounce where it was coming in at 42.6 or something, 42.43 meters per second, and then it bounces back at around the same speed about. So any questions on that one? Okay, everybody give Gabe a hand down there. Nice, yay. Yay. Okay, and if Gabe, if you, perfect. So I think the next problem, I can't remember. Let's see. The next problem, I don't think. Let's see. That was number. Oh, so the next problem is number 7. So let's do that one together, actually. It says, what force does the ball exert on the bat in number 6? Can you guys unmute yourself? What force does it exert?
1320 newtons.
1320 Newton. That's because of Newton's third law. So that one should be pretty easy. So if the batter hits the ball with a force of 1320, the ball hits the bat with a force of 1320 in the opposite direction. Okay, so then the next one we're looking at is number 8. And this one's a totally different problem. So here we're looking at a rocket. So I'd like you to do both parts A and B for this one. Okay, so let me put you in your rooms, breakout rooms.
What are you doing to my beautiful instructions?
So you guys are doing okay?
Yes.
No confusion? You get everything?
We can just divide by 10 to get the mass, right?
Yep, you can. Yep, that would work. Okay, all right. guys okay? Any questions?
No, I think we're good.
Okay. You doing okay? Everything fine?
I think we're a little confused.
Okay. So the force diagram should be pretty easy, right? How many forces?
Mhm. Two.
Two? Okay. And which one's bigger? The one down or up?
Up.
So how would you go about finding the net force? What would you have to do with those two forces?
Subtract.
Subtract them. So when you're thinking of the impulse equals change of momentum, remember it's assuming it's a constant force. It's force times time equals change of momentum. So you'd have to subtract those two to find the net force in that equation. And the thing we don't know is time. On the right-hand side where we have change of momentum, that's mvf minus mvi. What's the initial velocity of that rocket, assuming it's sitting on the ground?
0.
0. So if it gives you the weight, how would you find the mass of the rocket?
Divided by 10.
Right, divide by 10. And so they give you the speed that it has to get up to. So you should know everything except for time then. Okay?
Okay, thank you.
Yep. Doing okay?
Yep.
Okay. No questions?
No.
Okay. Doing all right? Yeah, okay. No questions? No, okay.
I have like 3.
Doing okay?
Yeah.
Mm-hmm.
You have any questions?
No, I think we got it figured out.
Okay.
So.
Doing okay?
Yeah.
Any
Yeah.
any questions?
I think we're okay.
Okay. Katie, can you hear me? Okay, can I have a new volunteer to kind of share their whiteboard with us? So again, you just click the green share at the bottom, pop-up will come up, and then you just hit the blue link that comes up where you share it with everybody. Somebody definitely wants to share. I guarantee you, you're going to want to share. Okay. So there's the nice force diagram there. I don't know, Jaden, I don't know that I'd call it a normal force, though. I suppose on the ground it would be a normal force, but probably a thrust but I think
Right.
the picture looks good. And then just kind of walk us through, how did you get the answer there?
So we used the weight of the rocket, then divided it by gravity to find the mass. Then
Okay.
we did change in momentum equals the final mass, the mass times the final velocity minus the mass times initial velocity, and we use that to solve t.
Okay, so, and you got what, 4.29 seconds? So, all right, so let me, so you did 4.36 e to the fourth divided, what'd you choose for g? I'm just curious, 9.8 or 10?
I think Justin
9.8.
chose 10.
9.8? Okay, 9.8. Okay. Oh, okay. I got a slightly different number there. I got 4,448. The only reason I'm pointing that out is I got a slightly different answer. It's pretty close to what I got. I had 4 point something, but my answer, I think I got, let's see, I got like 4.4 seconds. So, but your logic totally looks the same as my logic. So I think it's just the mass. You and I differ on the mass. Maybe it was because of a different number you used. Maybe you used 9.81 or something. I don't know. So, probably around 4.3, 4.4, 4.3 seconds, something like that. So any questions on that one? So everybody give Gina a hand. Yay. All right, and I think I'm going to get another snapshot of everybody. So if you could turn on your camera again, at least give me the P symbol, something like that, or a thumbs up. If you can turn on your camera and count of 3. 1, 2, 3. Okay. Let me save that file. Save. Capture 2. All right. All right, so let me share my screen with you. So I think that's all we're going to do for today for that. Let me go back to the calendar. Okay, so couple things I want you to do today for homework is, first of all, I would like you to finish up that worksheet, which we kind of have most of it done. I think we only had maybe 3 more problems to do. So kind of collaborate on that. Don't just do it all yourself or divide and conquer. Kind of collaborate, so I don't think it'll take that long. That way we can whiteboard it pretty quickly tomorrow. I also want you to get data for the next lab. It's called Collision Lab. And there's directions here. If you click on this and open it up, there's directions that you can follow. And there's also the response sheet so you can see it. Of course, we're going to whiteboard it. You'll never turn in the response sheet until after we whiteboard it. But I'd like you to get the data. The problem with this program is it uses a Java program, and so I want to take you through. I want to actually kind of do it a little bit so you can see if some of the problems that you're going to see. If you click on this and then try to open it, it won't work because it's a Java program, and you have to do it in Firefox. So I'm going to copy this URL, and it has it, by the way, it says that in the directions that you download. I'm going to open up Firefox app. Paste it in. No, paste it in. And again, you're going to hit the play. When you hit the play, a pop-up like this will come up and you'll think, oh my gosh, I can't do this. But go ahead and click on it anyway and click allow, and it will work. And so what you're going to do is, I'm just going to go ahead and let it collide once. You're going to have these 2 air pucks that kind of collide and they bounce off one another. Let me restart it. And what I would like you to check, by the way, this is all in the directions, but I would like you to click center of mass. Notice when I do that, this little X pops up here. So center of mass. Momentum diagram, this little diagram down here comes up in the lower right. Kinetic energy, it kind of tells you the kinetic energy. And I want you to notice there's this slider, it goes from elastic to inelastic. And you're going to click on more data. So you can move these to wherever you want. You can change the velocity to wherever you want. I'd like you to make all kinds of different collisions, like maybe they're coming toward one another. Maybe one of them's not moving and the other one is moving. It's going to hit like that or whatever. maybe they're going in the same direction, but one's going slower, it's going to catch up and it's going to hit or whatever. But what I want you to do is notice it tells you, I don't know if you can see this down here where my cursor is, but it tells you what the momentum in this data chart. It tells you what the momentum of the red one is and the green one is before the collision. And I'm going to let them collide. After the collision, it also tells you what the momentum is. So what this lab is, let me replay it, so restart. What this lab you're looking at is you're looking at what the total momentum is before the collision and the total momentum of the system after the collision. So right here, if I want to figure out the total momentum before the collision, it's just 0.7 plus 0.5. And then after the collision, I can add it up and figure out what that is as well. So you need 6 different data points, but where's that? I think I have to download it again. Let me open it back up again. I want you to get 6 different data points. This is number 3. 6 different data points, but at least 2 of them I want to be elastic collisions. So I'm going to come back to my lab here. Do you see where it has elastic here? So elastic collision is when you're going to have it all the way over on the right. So you just do at least 2 collisions, and they could be however direction you want. Okay, that doesn't matter. Want 2 collisions that are elastic. And I want, where's that? Lost my place again. I want 2 collisions that are perfectly inelastic. So 2 collisions that are perfectly inelastic. It's way over here on this end. And then finally, I need to have 2 collisions that are just simply inelastic. So let me go back to this. So somewhere in between would be just inelastic. So at least 2 collisions that are elastic, 2 collisions that are perfectly inelastic, and then 2 collisions somewhere in between. Those are just simply called inelastic. So I know it's a little confusing. Let me go over that again. All the way over to the right is called elastic. All the way over to the left is called perfectly inelastic, with the IN in front of it. In between is called just simply inelastic. So it's the same word as over here on the left, inelastic, but this is just called inelastic in between. But if it's all the way over to the left, it's called perfectly inelastic, right? And you can do more than 2. It's really easy to do these. I don't think it'll probably take more than probably 15 or 20 minutes to get all the data or so. Let me go back to that lab, if I can find it here. This 5th one is something I just want you to make some observations on. It's not so much you're getting data for the last one, but I've given you these words like what elastic. I haven't even defined it. I want you to watch the collision and notice what happens when it's elastic. And you'll notice that it looks different than when it's perfectly inelastic. So that's B. You'll see that it's different. And the center of mass, I want you to look at that X and notice about before the collision and after the collision, something about that X. You'll just see something. That's the center of mass again. And then down here, this momentum chart, this is kind of a conceptual tool that'll help you with momentum a little bit. And so I just kind of want you to make some observations about that. So let me go back to, so that's kind of what I'd like you to do is I'd like you to get that data today. That way you can kind of whiteboard it. I would kind of like you to work on your groups. That way you're not totally by yourself. You're kind of working together. You can divide and conquer, I suppose, if you want to. But I think it would just be easier if you could schedule time sometime and like, hey, let's do this lab and get our data really quickly. Now I have to talk about this attendance quiz. So for this attendance quiz, here's the code. So copy down this code. It's lowercase k as in kangaroo, 5, R as in red, T as in Tom, uppercase D as in dog, lowercase p, lowercase f, the number 9, and the lowercase z. Lowercase k, 5, lowercase r, lowercase t, capital D, as in dog, and then the rest are lowercase PF9Z. Okay, now having said that, there's only 4 questions there. To reward the people who actually presented, you don't need to actually, you don't have to do this if you don't want to. You can if you want to get some bonus. It's not that hard. It's kind of over the stuff we did. But so Aiden, you presented, let's say JJ, Gabe, and Jaden. You guys don't have to do it, but everybody else will have to do it. It's only 4 questions. It's not that hard. And again, those people I named off, if you want to do it for bonus, you can. It's not going to be a lot of bonus, maybe a couple points or something. All right. So the next time we are together is on Wednesday. Let me go back and show you Wednesday really quickly. Is Wednesday we are going to be, well, we'll finish worksheet 1, but then we're on whiteboard the graphical mathematical models. Also, we were asked to put on our calendar stuff that we'll accept late. If anybody forgot to do the internet homework, this last one is due on Sunday, I'll accept it with a kind of a penalty, but I'll accept it late. Any questions? Sorry, I kind of went a little long there. That's it for today then. See you later. Stay safe. Bye.